All right, today we're going to do our lesson on what, guys?
Concrete.
All right, we're going to talk about concrete. Make sure that you open up your Google form, follow along with this presentation, answer the questions, and then we're going to get ready for the hands-on portion of this. So let's get started. So if I was to ask you, if you're outside in front of the school, what are you standing on, cement or concrete? Take a couple seconds and think about it. Cement or concrete, what are you standing on? Okay, for those that say concrete, that is correct. Okay. Also, cement is, let's just think of concrete as you're making a cake. Cement would be the flour that you need for the cake. Concrete would be the cake. Okay. So what happens is cement is actually needed to make the concrete, just like flour is needed to make a cake. All right. So let's go on. Right here, this is a video when I actually toured high school and I asked that same question just to throw it out there. I asked the students, are we standing on cement or concrete? Just I was listening to the dialogue back and forth. Like I said, there's no wrong answers. That's just a question that I posed in the beginning of the lesson. I'm going to share this link with you. It's going to be it should be underneath the assignment. Okay, what is concrete? Concrete is actually a mixture of four basic ingredients. You have your fine aggregate, you have your coarse aggregate, you have your Portland cement, and you have your water. So let me show you what those ingredients are. Okay, you have your fine aggregate. This would be it right here. This is sand, okay? This is your fine aggregate. This is sand. Yeah, I got bags of sand in my house to teach a lesson that you're laughing at. Okay, this is your coarse aggregate. This is gravel or rocks. Sometimes they might be bigger, but this is your coarse aggregate, okay? We also need water, okay? I just picked up a bottle of smart water. But what happens is when you make concrete, you want to make sure you have fresh, clean water, okay? That actually helps with mixing it, okay? Fresh, clean water. I just got this bottle of water just so you can see. And also, last but not least, we're missing our Portland cement. That's in the shop. I'm doing this lesson at home, but got to have your Portland cement. I will show y'all what that looks like in the classroom. It's the same thing, same characteristic as sand, but it's more like of a powder and it's gray. Okay, so those four ingredients, that's what's needed to make concrete. Now, when these four ingredients are mixed together, a chemical reaction takes place, what is called hydration. This chemical reaction is what causes concrete to harden. Okay, concrete does not dry out, it's hardened. Okay, concrete does not dry out. Remember, I said that concrete does not dry out, it hardens. Okay, the result of this chemical reaction can take place even if concrete is underwater. Okay. Although concrete will harden within several hours of mixing it, it does not reach its design strength for 28 days. It takes 28 days for concrete to reach its design strength. Cash, how long does it take concrete to reach its design strength? Wasn't paying attention. I said 28 days. How long?
28.
How long?
28
28 what?
hours.
I said 28 days.
Oh,
Oh my
28 days.
goodness. It takes 28 days for concrete to reach its design strength. Okay. Concrete driveways can be driven on after about a week of curing. Okay. Now we're going to talk about the ingredients. I just showed you. Remember, Portland cement? It's a finely ground powder made of lime, silica, aluminum, and iron. This ingredient is what is actually responsible for the hydration. Okay. We have our coarse aggregate, which is gravel or rock. We have our fine aggregate, which is usually sand or crushed stone. Then we have our water. It must be clean, potable water. You must be able to drink it. Okay, water and Portland cement are only two ingredients needed to make concrete. Although the decreased shrinkage, aggregates act mostly as a filler material, make up 75% of the volume of concrete. Okay, so what happens is you only need water and Portland cement to make it, but what happens is it'll shrink down tremendously if you do not have your aggregates in there. That's the gravel or rock. So it's just a filler material. Now we're going to talk about the states of concrete. You have plastic concrete, which is actually still wet and mixable. Okay. Then you have green concrete, which is hardened but not has reached its design strength. Okay. Then you have cured concrete, which has reached its design strength after how long? How long, Cash? How long does it take for concrete to reach its design strength?
Um,
28 days.
we see 28 days.
Okay, man. Remember, plastic concrete, that's when you're still mixing it in the pan. Then you have green concrete. That's when you actually poured it. You got it in your forms, and it's starting to harden, but it's not quite there. Then you have cured concrete. It has reached its design strength in how long, Cash?
28 days.
There you go, 28 days. Okay, design strength, pound per square inch that the concrete has designed to carry. Let's go ahead. Now we're going to talk about some of the safety concerns with concrete. If you look at the image that I have on the slide, you always want to wear your gloves when you're dealing with concrete. You do not want to mix it or handle concrete with your bare hands. You can look at the image. You can see some of the burning that has caused. And then also you want to make sure that you have your correct PPE on. You want to make sure that you have a mask on because you don't want to breathe this. I also have a video that's posted. You have to watch that too about the different effects, what can happen if you breathe the cement dust. Now we're going to talk about the admixtures. Okay, admixtures, materials added to plastic concrete that will change the characteristics of cured concrete. The first thing we're going to talk about are accelerators. Accelerators are designed to make concrete cure quicker. Okay, this is the most commonly used of these are calcium. So what happens is if we're working outside, it's cold outside, we're getting our forms done, we're building a house. You want to make sure you add calcium. That will make sure that it hardens faster. Hydration can take place faster. You don't because if in cold weather, concrete cures a lot slower. Okay. Then you want to talk about retarders, an admixture that will slow down the curing process. So we'll use this when we're doing concrete when it's hot and humid. You want to add a retarder. Plasticizers, admixtures that will improve the workability of concrete. All right, now we're going to talk about the special types of concrete. This is mass concrete. This is used for dams, spillways, and large structures. Here's the image right here. Then we're going to talk about special types of concrete. We have high strength concrete. This concrete with a design strength of 6,000 psi or more. So you see this. This is a bridge. Okay. Curing methods. Now we're going to talk about curing methods. Since hydration stops when concrete is allowed to dry, it must be kept moist to cure properly. So when you have concrete, you want to make sure that you after you just formed it up, everything's down. You want to make sure that you constantly spraying to keep it moist. Okay. Most commonly is flooding, which involves spraying concrete with water while it's curing.
Well, I go right back.
Okay. So when you come back, all right. So you want to keep spraying concrete when you're using it. All right, curing methods. Curing compounds. These are waterproof barrier over the concrete surface. Green concrete that keeps moisture from escaping from the concrete. Okay. Also, we have curing paper or plastic sheathing. You lay that over after you spray it. It keeps the moisture inside. Then we also have mats and blankets. Use that in the wintertime, insulating blankets as well. Now we have the following videos that you need to watch to complete this lesson. If I ask you, what is concrete? Concrete is four basic ingredients. What are the four basic ingredients? We have a fine aggregate, we have coarse aggregate, we have water, and we have Portland cement. Okay, then I'm going to ask you another question. Curing concrete. Explain curing concrete to me. What's the process? Then if I ask you about concrete silica, you should be able to explain that. And the last video that we have types of mixtures in concrete. Tell me the mixtures. How does the property of concrete change when you add these mixtures to the concrete? So complete the Google form. Once that is complete, let me know so we can get on for the hands-on portion.